day, my amiable viewers. My name, as you already know, is Israel Guy. You are welcome back to my channel. Please, I always appeal to you. After watching my videos, kindly subscribe, press the like buttons, and also to share, because your subscription encourages us and also keeps this channel going. In our today's video, I'll be teaching you some important areas of organic chemistry. Notable among them is alkanols. Last time we talked about alkanes. We also discussed alkynes. Today we are going to talk about alkanols. Alkanols. Alkanols are organic compounds that contain the hydroxy group, OH group. That is the meaning of the hydroxy group. Remember, it's attached to something. So, any of the alkanes that contains the hydroxy group, they are known as alkanols. Alkanes are usually the parent hydrocarbon. Remember, alkanes have the general molecular formula CnH2n plus 2. But in this case, we are replacing one of the carbon atom, one of the hydrogen atom with the hydroxy group. In which case, we now have the general molecular formula of the alkanols as CnH2n plus 1. Then you add OH. This OH is called the functional group. Remember, the functional group in a compound determines the chemical characteristics of the compound. It gives the compound its identity. By the mentioning the functional group, you know the group to which the compound belongs. So, like we said, alkanols are organic compound that conform to the general molecular formula CnH2n plus 1 OH. They are formed by replacing the alkane, this E of the alkane, with OL, in which case we have the alkanols with the absence of this S. But since we are dealing with many, you can add S to it. Replace the E of the parent hydrocarbon with OL. For example, we have methane with the general formula, or with the molecular formula CH4. If you replace this E with OL, it becomes methanol. You have replaced this E with OH. And based on this formula, we now have CH3. The remaining hydrogen atom replaced with OH, making CH3OH, methanol. So the same thing applies to all the other members of the homologous series of alkanols. Now, let's go into some other areas of this discussion or topic. Now, you have three different groups of alkanol, in which you can call it classification of alkanol based on the number of OH they occupy. The first one is monohydric alkanol. Monohydric, they have only one OH group. For example, you have CH3OH, C2H5OH. All these one have only one OH group, no matter how long the parent hydrocarbon is. They have only one functional group, only one OH. Not just one, not that have only one functional group, actually, they have only OH group. So they are called monohydric alkanol. You also have another group, dihydric alkanol. They have two hydroxy group attached to the alkane, CH3OH. Sorry, CH2OH. The remaining bond is used for this, CH2OH. This, and if you grade this one, it has two carbon atoms, it becomes ethyl, 1, 2, with a hyphen, diol. You see the ethane. From ethane, we replace E with OL. In this case, you have two OL. So ethane 1, 2, diol. You also have, this one is called dihydric alkanol. You also have a trihydric alkanol. You have a trihydric, which is the third one. Alkanol, which you have CH2OH here, CHOH, CH2OH. Actually, we are putting this structure like this because this one can also be written in this form. HA. That this one, this carbon must be bonded to 4 other atoms. 1, 2, 3, 4. But based on formula method, based on the formula, you have this. This is trihydric alkanol. That's the general name. The specific name is 1, 2, 3. You have propane, propan. 1, 2, 3 triol, which is also known as glycerol. We'll come in contact with it again when we are dealing with fat and oil. So this is the alcohol present in fat and oil. So these are the classification of alkanols based on the hydroxy group, number of hydroxy group they have. Remember, among these alkanol, you have the first member, which is methanol, CH3OH. This is the first member of the group and the smallest. This first member is also known as wood spirit. Wood spirit. That is very, very volatile. The boiling point is very low, can easily vaporize. You know, spirit. So it's known as wood spirit, and usually based on this the literature about it, it usually causes blindness when you inhale it. So that is the first member. They have the second member. This is not too popular. You have the second member, which is C2H5OH. This one is called, this is methanol, while this one is ethanol. This one is second member and by far more versatile. That is of more use than any other alkanol. Most of the drink we take, burial, marriages, this is what they normally use. Ethanol, boiling at 78 degrees Celsius, is what they normally call gin. It is incorporated into gin that they use for all those ceremonies. The direct ethanol you get, which is about 99% absolute ethanol, cannot be consumed. If you consume it, it can damage the liver instantly because it's too concentrated. So what they use for your gin is what they already added other things, including water for dilution. Hand sanitizers, perfume, and other things you use is made from this ethanol. Even as at that, they still dilute it, so it cannot be consumed. It cannot be consumed at all. Normally used for laboratory purposes. So that is. They also have the other one, propanol, butanol, etc., based on their homologous series. All of them have homologous series. So we have classified alkanols based on number of hydroxide group they occupy. Now let us also consider it based on the position of the hydroxide group. In which case, we have the primary alkanol. Primary alkanols are those alkanols that have one alkyl group attached to the carbon atom carrying the hydroxy group. For example, let's say you have a CH3OH. This is methanol. You see, this is an alkyl group. I told you the first class that alkyl group is an alkane that have lost one hydrogen atom. That space where the hydrogen atom was lost is used to bond with other things, other functional group, substituent, or whatever, or what have you. So you see this alkyl group, it has attached to this OH group. So this is primary alkanol, having only one alkyl group, no matter how long it is. Let's assume you have CH3, CH2, CH2, CH2OH. This is 1, 2, 3, 4, butanol. You see it, whether it's butanol or not. This compound, which is from butane, has one OH group at the end, meaning that this butyl is attached to one OH group. Therefore, it's a primary alkanol. Remember, it's called butanol. Butyl group attaching to one OH group. Butyl because it's an alkyl that has lost one hydrogen atom. So no matter how long or short, so long as it's an alkyl group that is attached directly to one OH group, is a primary alkanol. Then we also have the secondary alkanol. Remember, we are classifying it based on the position of the OH group. Secondary alkanol. Secondary alkanol have two alkyl groups attached to the carbon atom carrying the OH group. For example, let's say you have CH3 to CH3, then OH. This one will have to be hydrogen. You can put the hydrogen group up or down. So this one is two alkyl group attached to this. We can also have CH3 to C. You can open it if you like to C to OH to H to CH to CH3. So this one is also an alkyl group. Remember, it's an alkane, ethane, that are lost one hydrogen atoms. This is ethyl. This is methyl. So it's an alkyl group also. So two alkyl groups, they may be the same or different, attached to carbon atom carrying the OH. The same thing with this, but naming them will differ. See this, you count the number of carbon atoms from side nearest to the functional group. 1, 2, 3. So this is propan 2-O. This is propan 2-O. All of them are propanols, but you have to show them where the OH group is by naming them using the IUPAC form or format. Then you have this is nearest to OH group. 1, 2, 3, 4. Butan 2-O. So these ones are known as secondary alkanol. You have propan 2-O, butan 2-O. They may be longer, but the important thing is that two alkyl groups are attached to the carbon atom carrying the functional group. Then you have the tertiary alkanol. Tertiary alkanol have 3 alkyl groups attached to the carbon atom bearing the OH group. You have, for example, CH3 to CH to C to CH3. Let's put up this time around. You have CH3. It can be longer, whether it's longer or not. Let's use another example again. CH3 to C, H2 to C to OH to CH3. Can also be longer than this. This CH3 or CH2, CH3, whichever way, name it accordingly. So these ones are tertiary alkanols. Look at them again. If you want to name them, start counting. You can count from either side, inside you like. Let's start from this side. 1, 2, 3. So this is a methyl group. 2-methyl propan 2-O. You see, this is the IUPAC name for the specific name for it. In a subsequent class, one of the classes we are going to have next, we'll do chemical nomenclature, naming of organic compounds. That will make everything very, very easy for you. Please don't forget to watch it. That's why you have to subscribe anyway. So for this, you start from this side. 1, 2, 3, 4. Remember, you can start from any side since they are the same distance from the functional group. It's not the alkyl group that matters this time around. So you have 2-methyl butan 2-O. So these are tertiary alkanols. So that is that on the classification of alkanol based on the position of the OH group. The previous one was based on the number of OH, the number of hydroxyl group. This time around, based on the position of OH group. Now, all these alkanols can also be distinguished from each other based on their chemical properties. For example, the primary alkanols, which you just did, having one OH group at the end of the alkyl group, can undergo oxidation using potassium heptadichromate 6, K2CR2O7. Remove this from 14, become 2. Potassium heptadichromate 6. Remember, you must always add H2SO4 to acidify it. If not, the reaction will not work. That's why you call it acidify K2CR2O7. If you acidify the solution, then use it as to oxidize primary alkanols. You have alkanon first, followed then later full oxidation. That's partial oxidation. Full oxidation will give you alkanoic acid. This question is usually asked in most of the examination bodies. Then again, you can also oxidize secondary alkanols because it has acidic hydrogen now. If you oxidize secondary alkanol, it will produce alkanol. But tertiary alkanol, because you have alkyl group on all sides, there is no hydrogen available, so it will not be oxidized. That is how that one is. And remember, to carry out tests for this alkanol, distributed test, we only use a test we call Lucas test. Lucas, C-A-S, Lucas test. It's actually a solution of zinc chloride in concentrated HCl. So subsequent class again, we'll go through some of them. And if you have any question, don't forget to ask in the comment section. My WhatsApp number is also there for more clarification. God bless you. Thank you very much.